This is SpaceTime, Series 25, Episode 73. Coming up on SpaceTime, discovery of the most powerful pulsar in the distant universe. NASA returns to Australian skies to study our nearest stellar neighbour. And China launching more spy satellites as it continues to prepare for war. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered one of the youngest and most powerful neutron star pulsars ever seen. Neutron stars are the super-dense remnants of stars far more massive than the Sun, which have exploded in spectacular core collapse supernova events at the end of their lives. It involves the mass of an entire star, between 8 and 20 times the mass of our Sun, suddenly crushing down into the stellar core. Now, the amount of gravity compressing down onto the center of the star is so unbelievably immense, it's quite literally forcing together the electrons and protons which make up the star's atoms, turning them into neutrons, hence the star's name. The end result, called a neutron star, is a strange exotic object, just a dozen or so kilometers wide. But they're the densest objects in the universe other than black holes. And now, scientists have found what may well be the youngest and most powerful neutron star pulsar anywhere in the distant universe. The claim is based on observations from the National Science Foundation's Very Large Array Radio Telescope in New Mexico. The data indicates that a bright radio emission being powered by a spinning pulsar's magnetic field may have only recently emerged from behind a dense shell of debris generated by the supernova explosion. The object, catalogued as VT1137-0337, is in a dwarf galaxy located some 395 million light-years away. It first appeared in data from the Very Large Array Sky Survey in January 2018, but wasn't there in an earlier image of the same region of space made by the Very Large Array's first survey in 1998. As astronomers peered through the archival data, they found it continued to appear in subsequent sky survey observations by the Very Large Array in 2018, 2019, 2020, and 2022. One of the study's authors, Dylan Dong from Caltech, says what they're most likely seeing is a pulsar wind nebula. Now, a pulsar is a rapidly spinning neutron star, and a pulsar wind nebula is created when the powerful magnetic field of the neutron star accelerates surrounding charged particles to nearly the speed of light. The findings, reported to the American Astronomical Society's meeting in Pasadena, California, suggest that based on its characteristics, this is a very young pulsar, possibly only 14 years old, but almost certainly no older than 60 to 80 years. Now, comparing this Very Large Array Sky Survey scan to data from earlier Very Large Array Sky Surveys revealed 20 possible luminous transient objects that could be associated with known galaxies. But Dong says this one stood out because its galaxy is experiencing a burst of star formation, and also because of the characteristics of its emissions. The galaxy, catalogued as SDSS J113706.18-033737.1, is a dwarf galaxy containing about 100 million times the mass of our Sun. Now, in studying the characteristics of the signal, the authors considered several possible explanations, including the likelihood that it's a supernova, a gamma-ray burst, or a tidal disruption event in which a star is shredded by a supermassive black hole. But after carefully weighing up the evidence, they concluded the best explanation was the pulsar wind nebula. Now, in this scenario, a star much more massive than our Sun explodes as a supernova, leaving behind a neutron star. Now, most of the star's original mass is blown outwards as shells of debris. In the middle, hidden behind all this debris, the neutron star, the collapsed core of the original star, spins very rapidly. And as its powerful magnetic field sweeps through the surrounding space, it accelerates charged particles, causing radio emissions. Now, initially, these radio emissions are blocked from view by the shell of explosion debris from the supernova event. However, as that shell expands outwards, it becomes progressively less dense, until eventually the radio waves from the Pulsar Wind Nebula can finally pass through. And that would have occurred between the first observations in 1998, when nothing was seen, and the later Very Large Array Sky Survey observations in 2018, when the first detection was made. Now, possibly the best known example of a pulsar wind nebula is the famous Crab Nebula in the constellation Taurus, the Bull. The Crab Nebula is the result of a supernova that shone brightly in the year 1054. It was clearly visible by sky watchers of the time and noted in the annals of Chinese astronomy. And even today, almost 1,000 years later, the crab remains one of the best known and studied objects in the sky, easily visible using even small backyard telescopes. But this new object is some 10,000 times more energetic than the crab, with a stronger magnetic field. While the object is most likely a pulsar wind nebula, it's also possible that the extremely strong magnetic field being generated means the neutron star is actually a magnetar, a class of supermagnetic object, and the leading candidate for mysterious deep space explosions known as fast radio bursts, the nature of which are also mysteries. This is SpaceTime. Still to come, NASA returns to Australian skies to study the nearest star system to our own, Alpha Centauri, and China launching 4 more spy satellites as it continues what Beijing describes as its build-up to war. All that and more still to come on SpaceTime. NASA has undertaken its first ever launch from a privately operated commercial launch pad outside the United States. The mission from Equatorial Launch Australia's Arnhem Space Centre near Nhulunbuy, some 640 kilometres east of Darwin in the Northern Territory outback, was the first of 3 suborbital flights the space agency plans on undertaking. The missions, all using Black Brant 9 sounding rockets, will each be carrying a different scientific payload. The first was designed to study our nearest neighbouring star system, Alpha Centauri, using an X-ray quantum calorimeter developed by the University of Wisconsin-Madison. The flight, which was delayed by just over an hour due to rain and strong winds, used unique X-ray detectors cooled to just 1/20th of a degree above absolute zero. The flight, which reached an altitude of over 350 kilometres, measured interstellar X-rays with unprecedented precision in order to better understand the interstellar medium between the stars and its influence on the structure and evolution of galaxies and the stars they contain. The second flight, which is happening today, is carrying Cystine, the suborbital imaging spectrograph for transition region irradiance from nearby exoplanet host stars. Developed by the University of Colorado Boulder, it'll study how ultraviolet light from the stars in Alpha Centauri affects the atmospheres of any exoplanets orbiting around them, including any gases that could provide telltale indications of life. The third mission, targeted for next week, will carry JUICE, the dual-channel extreme ultraviolet continuum experiment, also from the University of Colorado Boulder. JUICE will measure a so far understudied part of the extreme ultraviolet light spectrum from stars less massive than the Sun, and how that affects the atmospheres of any orbiting planets. The Arnhem Space Centre was selected as preferred launch site because of its location, allowing astrophysics studies that can only be done from the Southern Hemisphere. But getting the 13-metre tall Black Brant launch vehicles to the remote launch pad site wasn't easy, requiring a barge ride and some 70 NASA staff and multiple container loads of specialised equipment, all in all a significant logistical undertaking. Astrophysicist Brad Tucker from the Australian National University is at the launch site for the missions and says it's been a while since NASA last launched rockets from Australian soils.
Yeah, so this is called XQC, X-ray quantum calorimeter. So kind of like an X-ray telescope, essentially looking at what we call soft X-rays and measuring the diffuse X-ray background, so kind of the background in the universe in X-rays. And there's a lot of reasons for these sources. It's very important to understand in terms of the evolution of the universe, the reason this X-ray light is there. Now, of course, with all of these missions, they're sounding rockets. They don't go into orbit, but they do go into space, and they are looking in targets in the southern skies, meaning they needed that southern launch. And so for XQC, it's had multiple northern launches, but as Dan McCannon, someone I was able to chat to, was desperate and has been desperate to launch from the south. Wind and rain caused havoc for the launch, so we had a total of an hour and 14 minutes worth of delays. But yeah, in the end, eventually the launch was perfect, great success. The science teams got the data they needed, or at least they wanted, at least the preliminary estimates. And yeah, the recovery went well. So the motor was recovered pretty quickly. The following morning, it was actually quite conveniently located near a road, Central Arnhem Road. And then the science payload was recovered the next night, Monday night, and returned about 5:30 p.m. So yeah, so look, everyone counts it as essentially successful launch, and everyone was pleased. And look, we were all pleased to be there to also see it.
Is it a viable location to carry out commercial launches?
Look, I think so. The whole benefit up there is you can have these remote locations for things like sounding rockets or bits. You have land to recover on them. If you need, you're near the equator. It's a great place, obviously, to go then. Rockets like to launch near the equator. It's the fastest point, the Earth is spinning. And so there's a lot of these benefits. And even though we did have wind and rain, you get these periods called the dry season where generally the weather is pretty stable. And even with a bit of wind and rain, they were still able to get it. How often are overseas launches delayed because of weather? Florida, French Guiana, those are all often delayed because of the weather.
Yeah, and here you get 8 months of the dry.
Yeah, exactly. And that's right. And that is the benefit. So yes, you may have to have launch and non-launch seasons, but it also means that you can have those. And with that predictability comes that reliability, and people can plan and schedule it. So given how big private commercial rockets and space is happening, more and more companies are coming online wanting to build those rockets, and they need places to build them. And there actually aren't that many spaceports, especially ones that can fit in. They're being swallowed up by a lot of the big companies, meaning that some of the smaller and medium-sized companies are having a hard time finding a spot.
Is the Arnhem facility too remote? Is it difficult to get to? And what about accommodation for those up there? Is it a case of bringing your own tent, or can you be in comfort up there?
Look, it was an interesting juxtaposition seeing a caravan on my left, 100 meters, and 400 meters on my right, a rocket. It was very remote. And by far, there's a lot more infrastructure to go, but they've made a good way already getting that. Accommodation is scarce, as you said. So getting tourism, which they want people to come and watch those rockets. There is a lot of work needed, but the town is behind it as well. And the traditional owners, they all see it, especially as a great pathway forward for the area. And we look at other places overseas where, there's a huge economy related to these rocket tourism, essentially, and they want that. They want it to become up there. And so, yes, there's work to be done, but I think people saw all of that potential with that first one.
And we've got 2 more to go, one on July the 4th. Happy Independence Day.
That's right. It's appropriate for the Americans who are there to launch. And a friend of mine is the mission scientist of that one, Kevin France, which will be a UV spectrograph to measure elements and properties of our nearest star to us, Sun Alpha Centauri. That's a mission called Cystine, which is a UV spectrograph to measure the properties of Alpha Centauri in what we call the near ultraviolet range, so just out of the range of the visible spectrum, a little bit further away than the ultraviolet light that burns us. And Goose is the third payload on the 12th of July, another ultraviolet spectrograph that's looking at the extreme ultraviolet, very short wavelength. Once again, Alpha Centauri. And, these are specifically because Alpha Centauri, it is that nearest star to us besides the sun. There's a lot of searching for habitable planets or potential habitable planets around there, and characterizing the star is a very important part of that.
That's Brad Tucker, an astronomer and astrophysicist with the Australian National University. Located just 12 degrees south of the equator in the Gulf of Carpentaria, the Arnhem Space Centre is ideally suited for equatorial missions. And the operators plan to ramp up operations over the next 5 years, eventually undertaking up to 50 flights a year using 3 launch pads now being developed at the facility. But it's not alone. As well as equatorial launch, work's proceeding on 3 other commercial launch facilities in Australia. Southern Launch are developing a polar launch facility at Whalers Way on the South Australian Eyre Peninsula near Port Lincoln. It'll be used to launch orbital rockets on polar trajectories over the Great Southern Ocean. The company also operates a rocket test range at Cunibba, 40 kilometres from Ceduna on the South Australian west coast. The range tracks west over the Nullarbor Plain, allowing rockets and their payloads to be retrieved after launch. Meanwhile, construction is also proceeding on the Bowen spaceport at Abbott Point on the North Queensland coast, which will be used for equatorial orbit launches by Gilmour Space Technologies' new Ares rocket. It's expected to have its first mission later this year, with rockets flying east over the South Pacific Ocean. This is SpaceTime. Still to come. China launches 4 new spy satellites as it continues its preparations for war, and later in the science report, Monkeypox continues to spread globally, and scientists still don't know why. All that and more still to come on SpaceTime. China has launched 4 more spy satellites as the communist nation continues what Beijing describes as its build-up to war. The country's latest eyes in the sky include 3 more Yaogan 35 spy satellites. The spacecraft were flown aboard a Long March 2D rocket launched from the Xichang Satellite Launch Center in southwestern China's Sichuan province. Beijing describes the spacecraft as remote sensing satellites, mainly used to conduct scientific experiments, land resource surveys, crop yield estimation for agricultural products, and for disaster relief and prevention operations. In reality, the Yaogan 35 are sophisticated military spy satellites. Analysts understand the Yaogan 35A and B series are both high-resolution reconnaissance imaging satellites, while the Yaogan 35C is a radar or signals intelligence gathering electronic surveillance satellite. Just a day before the 3 Yaogan satellites were launched, Beijing launched the new Tianjin-1 test satellite into orbit from the Zhuquan Satellite Launch Center in northwestern China using a Kuaozhou-1A carrier rocket. Beijing describes the Tianjin-1 as being mainly used for experiments in space, such as local space environmental detection. However, analysts say it's actually a new design lightweight signals intelligence electronic surveillance spy satellite. Since 2016, Beijing have launched more than 190 Earth observation, surveillance and reconnaissance satellites designed to provide near-continuous high-resolution and electronic monitoring of areas of interest to China. That includes at least 40 Gaofeng and 92 Yaogan spy satellites. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.